So I've got an image on the YZ plane with an image inserted into it, and I'm going to do the same thing on the XZ plane. I'm going to put in the image that I want. I'm going to sketch out a rectangle and constrain that rectangle to the image. The reason why I'm doing this is because I want to maintain symmetry, and I'm going to do that by constraining this midpoint to this rectangle on the YZ plane's endpoints. I'm going to now call out this constrained dimension, rename it width because I want to use width downstream. Before I exit the sketch, I'll rename it top view and turn transparency on. So I'll exit the sketch and create another sketch on the YZ plane. I'm going to use a 3-point rectangle and sketch out a rectangle to emulate the blade. I'm going to now use that width dimension. I'm going to get symmetry selected, type in width times 0.85, so 85% of width. So I've made it smaller than the actual blade because the way the surfacing works is I want it a bit smaller. I'll put a 10mm fillet, click OK, and just create a new sketch on the YZ plane, because while I'm in sketching mode I want to sketch the spline out because we're going to split the body later, so I'll do it now rather than later. That's pretty much right. So I'll turn off 2D sketches and start surfacing. So I can choose a freeform body from here, and I want to choose a cylinder. So the way to do it is pick a plane, pick a point, which is about there, and start putting in some dimensions. So I can drag this in or drag it out to however small or large I want it in terms of the radius, or I can put a dimension in. I can put in width divided by 2.5, which will get me on the inside of that sketch, which is what I want. Both directions. I'll choose the right view. I want to drag the length out to about there. I want symmetry on the Y axis or plane. And before I exit, I'll put 14 faces. That'll give me more control points or vertices, edges and faces to work with. So now that my freeform body has been created, I can now start manipulating it. So I've selected all those faces, clicked edit form, and located the triad at that point there. That's going to give me a chance to rotate it on that point. I'm going to now select it at a different point, choose the triad to be local to the freeform body, and just drag it out. So you can see I'm slowly starting to make form of the shaver body. So I'm going to do the same on the right side. Yet again, locate the triad there, drag it. So there's a filter selection where we've got all here, and I'm just going to choose control points and just start dragging it up. I find the key with freeform modeling in Inventor is slow, deliberate movements. You don't want to make drastic changes and affect the form too heavily, because it makes it difficult to change it later on. So here, instead of control points, we're going to select some edges here and just drag this up. So there's really no right or wrong way of doing it. as long as the form starts taking shape, that's the main thing. I find when it's at the corner, instead of having it locally, I put it to world view. It makes it easier to manipulate the form. So that's the top view, almost done. That little corner we can fix up later. So let's do the bottom. So I'm just going to select these bottom edges and drag them in. I'll do the same on this side. And drag it in. And now it's just a matter of getting the form right to how I want it. So the technology that I'm using here is NURBS with another technology called T-splines that was acquired by Autodesk around 2012, I think it was, and it was put into Fusion 360 and also into Inventor. So I'm using either control points or edges to get the form right. So you can see it's starting to take shape. Got to fix this little area up here. We'll get to that in a moment. So yeah, the Freeform modeling tools in Inventor allows you to create primitives, join the primitives together. It's got symmetry with it. It's got a couple of really nice tools, and in the next release it's going to get much better as well, with more features being added. I think similar to the ones that were in the original T-splines add-on that came with Rhino. So that looks pretty good. I probably want to fix this one up a little bit. It's pretty close. Like I said, I need to fix this one up and get that closer to the edge. That's about right. I mean, we can spend all day trying to get it perfect. That's pretty close for the side view. Top view, I'm going to select the edges here, drag them out. That's close to the edge. Select these two faces, drag them in. You're going to notice now that the image isn't perfectly symmetrical, but we'll get that to a level that I think is close to the form. And now we're just going to go along selecting the control points and getting a nice smooth image, or body I should say, to the image. So I'm just going to select these last couple of control points, and you notice that we're not close to the edge there, and we're going to use a tool called Match Edge. So Match Edge works by selecting the edge or edges. We'll take the tolerance off higher to 3 mil and matching it to an edge. You can match solid bodies, sketch lines, and the surface will form towards it, as you can see. So that's pretty good in terms of getting it close to the edge there. Like I said, the image isn't perfectly symmetrical, so I'm just going to stick with that. Select OK. I might just want to lift that up a bit and get it straight. That's pretty good. So before I exit the surface, I'm just going to select that loop. I'm going to crease it because I want to show that creased edge. Makes it easier to show. So now that my surface is done, we can insert an eye feature. This is something I created earlier. Pick a sketch plane. We're going to rotate it to where I want it. About there's good. We'll activate the sketch. We can move it, constrain it if we wanted to, but we'll just exit that. And we'll revolve this profile along this axis and edit this solid. We want to make it a cut, and we'll cut that straight through. Now we'll shell it. And we'll split the body. So we'll turn the sketches on. Whoops, we'll split the body. We'll choose that. Click OK. And that should be split. So, as you can see, we've split the body. And last but not least, we'll just put some fillets on the edges there. I'm going to select G2 fillets because I want it much smoother than a G1 or tangent fillet. And we can put that on the edge there, just to make it aesthetically better. I'm not too concerned about this edge because there's going to be a blade over it. We don't need fillets there for aesthetics. And that's it. So as you can see, the Freeform tools in Inventor can do surfacing about half the time as traditional surfacing methods. I'm going to just turn on some analysis tools just to show you the quality of the surface. So if we wanted to as well, Inventor's got the power of editing the form while you've got your evaluation tools on if you really wanted to. So it'll give you direct feedback of the surface and how it's behaving in relation to it. So that's the Gaussian side of things, and we just turn off analysis, and we can also put zebra lines on there as well. As you can see, it's a nice surface. There's no real breaks there. If we exit the freeform environment, we can look at the fillet. As you can see, there's a couple of breaks, but they're G2 breaks. They're not G1 where there's a sharp edge there. And in surfacing, the better the continuity, the better the surface. So G2 is better than 1, G3 is better than G2. So that's about it. I hope you've enjoyed the demo, and I'll talk to you guys soon.